G'day guys. Haven't made a video for a few days. I've been working on these detectors and had a lot of repairs lately. I've been fixing detectors for people from all over the world, and a lot of them we get is quite interesting because the customers have been told they are unrepairable, and we haven't been having a problem fixing a lot of them up. I'm starting to think that the art of mainly analog electronics, it's just not enough techs out there that know about analog, and everyone has learnt about digital, and no one can work on analog stuff. Well, very few people can work on analog equipment. If it's not switching up and down in 5-volt steps, they don't know what's going on. And to lose engineers, technicians that know about analog, to me, is really bad because at the end of the day, no matter what is digital, um, you got to interact with it. And to interact with a digital system, all your receptors are analog. Basically, your eyes are analog, they're not digital. Your ears are analog, they're not digital. Uh, Fingers are. I wonder what they're called digits for. Um, your brain is not digital, it's analog. The whole human body is analog, it's not digital. So we've got all this digital manipulation of what? Analog signals in most cases, unless it's designed to be stored or manipulated digitally, such as data. Uh, Basically, all the ins and outs is analog, and it's a digital interface in the middle of it. Some cases that can be a good thing, in other cases that can be a bad thing. But anyway, it's just the way of the world. Um, so a lot of the faults that I do get are all in the analog domain, and you start getting iffy faults, that noise issues and things like that, and people just don't know how to fix it. They got no idea. They wouldn't know. Looking at a millivolt of noise to a microvolt of noise, that's just a bit of a squiggle on a waveform on the oscilloscope. If they delve into the analog domain, they just don't know what they're looking at. I've spoken to a lot of uh, engineering type people, got no clue about a lot of the analog stuff. And in the early days, I did a course in digital electronics, and I never really used it, because all the things I was getting was mainly analog, and the digital interfaces. You know, you'd you'd just look at it and you'd say, okay, here's our analog in, here's our digital interface, and are we getting analog out as what we expect? And in most cases, a lot of the faults were in the analog domain, and for me, straightforward to repair. And if it was in the digital domain, all you'd have is the analog input stages working fine, and you'd have no output on the analog. And you check the analog's output stage, you say that's fine. So it's those multi-legged devices in the middle, and all you just do is get a chart of a rough circuit block diagram. You wouldn't even need a circuit diagram, and you could just see what did what, and you'd find where the signal stopped, and you replace a particular, digital IC, and it would all start working again. But most faults in all equipment, and I'm being very generic here. Most of the faults are in the power supplies. When these, I don't care what it is, if it's you can even say electric cars, or these detectors or anything as such. Anything that has a step down or a step up voltage conversion going on, it's usually the power supply. Power supplies seem to be the weakest link in a lot of designs these days. Um, especially if you're looking at these detectors, if you have a bad power supply design, it's going to make noise. Just the nature of how they work. If no one does any conversion in a detector and converts DC voltage into a sine wave, and then rectifies it and filters it. It's all done with switching devices, and the way it's done, it's quite efficient, but it's also very noisy. You've got to know what you're doing, and it's not just say, we'll get some high-speed diodes and some low ESR filter capacitors. It's not that. These things switch very fast, and it wants to travel all over the circuit board and get into places you don't want it. So, board layout's critical, stuff like that. Anyway, yeah, I've been doing some work on the 4500s. I've had a few 5000s turn up, and this is very interesting actually. I've got quite a few of them here. I think there's about 3 or 4 of them, 5000 detectors, and uh, the fault with each one is that it's noisy or going noisy, and it's interesting that in the 5000 series detectors, they just tend to be, even though they got lower gain than say the old 4500, they are more noisy, and they just are. They're noisy. Actually, as an example, I've got poor old No Ears on the bench. It's gone through a whole heap of new changes, and this detector's working really, really well. It's outperforming just about everything around the place at the moment. That's really, really good. Actually, I could switch him on. I'll just turn him on. Now, it's such everything is made to be so low noise that the threshold is extremely low. It's the way these things work. But anyway, I'll give you an idea. Now I'll just move some stuff away so we can have a listen. Okay, uh, my amplifier is turned up full, right? And I've got this running a fairly, what I would call, if I went detecting, a fairly decent amount of threshold. And its factory default set at the moment. It's in normal, deep. I can't really see if I can stick my head around. Um, it's on the double D coil running in cancel mode, and let it warm up a little bit, and it's fairly quiet. It's basically, it was quieter before, but like I say, the TV goes on. I've got a small heater over there running, and this LED light up here. If you ever buy one of these things, where is it up there? That thing, they make noise. They are noisy. Uh, I don't know if it's in the power supply itself or the actual light, but if I unplug it, a lot of the noise goes away. So that's the story of that. Anyway, what I've done here, I've looked at a lot of ways of driving the MOSFETs on the input stage. And lo and behold, yesterday, actually, I had some new MOSFETs turn up. And these are ones I'm getting done overseas. A small semiconductor foundry that, for a good stack of cash, will develop specific semiconductors for you to your own specification. And I've had some done before, and they were okay, but they were basically on par maybe a little bit better because it had less gate capacitance than the 2SK1334s, which are now not made anymore. So that's what was in the front end of every Minelab detector from the GP Extreme onwards, and it's a fairly good MOSFET. There's not a lot of decent MOSFETs around that'll work. So that was a bit of a problem. They were going out of production. I've tried using a lot of different MOSFETs, and I think I've just realised that a lot of the stuff that's out there, it's got a lot of problems. It's capacitance in every format, you know, element to element is too much, and it affects the detector. The resistance can be too much, and it affects signal recovery. And there's a lot of things, and a lot of these MOSFETs generate their own noise too. They have fringing field effect. Well, it's a field effect transistor, isn't it? It's a FET, MOSFET, metal oxide semiconductor. But they have an internal different structures. There's planar structures, there's vertical structures, there's stripe structures, and a lot of these internal structures. And when you start running these things and trying to block a lot of voltage, they actually start making their own noise. So we don't want that. That just obscures your signal. It's very, very low level, but because you're amplifying the signals many thousands of times, it can make quite a bit of impact on your signal. Anyway, on both of these detectors, I have installed the new MOSFETs on the input stages, and I've also changed out the old BS-84s that are the I think they're BS-84s, or am I thinking of the BS-80? I think that's in the older detectors. Sorry, the GP Extreme 3000 3500s. These have got 2N7002s or something in them. I've taken those out as well, and I've put some other devices in there. So at the moment, like I say, this you probably can't even hear it. It's completely running very, very loud. To give you an idea how loud it is, I'll just get a metal object and I'll just go and wave. I'll wave that over the coil. I'll just give you an idea. It's extremely loud. So, and like I say, I've got the volume up. I can turn the threshold up, but it's not going to prove a point. There, that's full threshold. But I'll just turn it down because it does. The threshold, it's got nothing to do with signal recovery. It doesn't improve or make it worse. It's just so you can just hear it, and you need to detect a change in the threshold. So if you want it blasting out, you know, it's probably a little bit counterproductive because if too much audio come in, well, let's try an experiment. Let's try a little experiment here. I'll get my little 1 millimeter piece of wire, and I'll put it. Oh, yeah, I have to wind this up again, don't I? Okay, we're going to wind this up, and you all know I hate doing this. Where's the handle gone? It's around that side. Okay, I have to undo that. Okay, up we go. We've got some kids' toy up there at the moment. I don't know why, but I have. There, that thing was sitting there. I was using it as a spacer because it's made of plywood. Anyway, okay, that's a little one. that's as sensitive as the 6000 I was playing around with. Uh, it wouldn't do any better on that little spec than what I'm getting out of this. Um, I don't even know if you can hear that. I will crank the threshold up, but it doesn't really do anything. We'll try it. Actually, I'll tell you something. It's my opinion only. I'll turn the threshold back down. Is that I was playing around with some. Well, I actually had an SDC 2300, and even with the SDC 2300 with the very small coil on it, it would not give a really good signal on that. And this does. This is 11 double D. That's absolutely outstanding. And how quiet that detector is. It is really quiet. As an idea, give you an idea, I've got the two banger here, which is a 2mm one. We'll give that a little bit of a hit over the coil too. And this is in normal mode. There's nothing fantastic going on. It's not in sharp or any of the other sensitive extra or anything like that. It's just normal timings. That's very good. Getting it up at the level right at the top of those lug mounts. So that is damn good. That is very good indeed. Anyway, I'm going to have to show some of the secret sauce on this one. I'll just drop this back down. If I undo that, it would help. There we go. Whoops. Okay, I'll have to go over the notes. Now, I did some experiments and I tried utilizing the drive directly on. I'll move this over so you can see what I'm doing when I'm pointing at. Because I know some of you guys want to probably try this. I'll zoom in a bit. As you can see, no ears. Okay, I'll get some. I think someone's knocked off my pointer. Damn. And I'm going to grab something that's metallic. Let me. Oh no, it's still here. It's buried. My bench ends up getting piled up on, and everything gets buried on the bench. But if you can see this, okay, this chip here, that one, that's the ADG 333. And if you see the way it runs here, it starts off at pin 1 here, closest to me, pin 10, 11 to 20. Okay, now these are configured differently on this detector compared to the GPs. You don't want to say, oh, well, it goes here on a GP, it'll do the same on this. No, it doesn't. You do that and you'll start putting your receive into your transmit and your receive, and you're damping into your transmit or something. It's all different pin out. So I'll have to grab my little notebook here. Okay. If you want to do this, you've got to make up the subboard as well, because this gives a lot more current to switch these FETs, and it makes a difference. It makes a good difference, especially with the new FETs I've got in there. They may look like the 2SK1334s, but they are not, because the 2SK1334s are sitting up there on top of my oscilloscope for one set. There's another set down here somewhere. They're getting hard to get those MOSFETs now, so you want to not throw any of them out. When you take them out, don't overheat them. get them out the minimum amount of heat, and when you get them out, make sure you don't subject them to any static. When you take them off the board, leave the gate, drain and source legs connected together so you can't get a problem there. But okay, if you want to make your own totem pole driver, what I have on this board here, the same way as that. Whoops, that's a bit too zoomed in too far. I'll give you. You can copy this. This is easy to do. I'll just put it there. Just freeze frame the video, and you can then copy it. Okay. So what do we got? We got a BC 807, BC 817. They don't have to be 817s or 807s, as long as you have a PNP and an NPN, and you have it connected up the way I have it there. Okay. I haven't got the two. I was going to say gate connections. I've been doing too much MOSFETs. The base connections. The base connections here and here. You just stick them together. You know, join them together. A bit of wire. You have the two emitters. Join them together with a piece of wire. Here, it says 100 ohm. You don't need to. You can put a small resistor if you want. You can have something like a 10 ohm resistor here if you really want. Doesn't need it. I've done testing and it doesn't need it. On the board, this one here, which is the NPN, on the collector of the NPN goes to 5 volts positive, and there's only one place you can get that off the board, which doesn't interact with anything and cause problems. I'll show you where that is. And minus 15 volts, the negative 15 volts, that's the same voltage that's used to switch the transmitter on the short pulses. Now the 15 volts, I've added extra capacitors, extra filter capacitors onto the detector to smooth out the rails, because if you start zooming in, it does have noise on it. It's because every time the transmitter goes on, it wants to pull down, let go, and up it goes, and it's all over the shop. You want to smooth that out. On the well, what I did, I tried driving it directly on pin 20. Pin 20 is the input for this ADG 333, and the way it works, you got your drive, you got switch, like a 2-position switch. That's your common contact. These are your switch contacts. Now the way it works is like this. Switch 4. Actually, this is, if you look at the schematic or the data sheet for this, it'll say switch 4A is a switch contact, and that is on pin 19. I got that confused. I thought it was 18. It wasn't. It's 19. Pin 19 has 5 volts on it. Okay, and that's also your tap point if you want to run the external totem pole driver. D4, that's just the common contact. Okay, that's your output. So that goes to your totem pole driver on these connections here. Okay, the other side is S switch 4B connection, which is pin 17, and that goes to your negative 15 volts. So how you'd wire this in, I'll show on the board now. These are just the voltages for the chip, the supply voltages, ground, VDD, VSS, and ground, 5, 6, and 16. You don't worry about the other connections. There's 20 pins on this chip. You only want these ones here. And you want to make this up. You can make this out of, any like the say for instance the NPN transistor. There's better ones than these around. There's lower noise ones like the 857s. And what would the complementary be? 847 or something. There's letters after the part numbers like A, B, C, D, E, F, and G, and the higher ones have lower noise figures. So if you can get a E, an 807E, I don't know if they make them in this series, but I know the 857s, 859 transistors, you can get them in E. They're about a dB.5 noise figure. Some of these can be high. You don't really want high noise devices switching the gates of those MOSFETs. So get rid of the paper, and I'll get in on here. I'll zoom back in. Okay, I tried to do in a bit of a logical color code on this one. The other one I did in just black wire, so can't see. But yeah, the positive, if you can see it there, there's a capacitor here and another capacitor there. I've tacked another one across it because I just wanted to make it a bit more cleaner. And you solder it to that capacitor, this side, my side of that capacitor. I don't really want to pick this board up and wiggle it around, but I'm going to have to, aren't I? Hang on. Now I need 3 hands. Hang on a sec. Okay. So, yeah, solder that 5-volt supply wire. This point, your negative 15 volts comes off the big filter capacitor on the other side of the board, but its terminals come through here and here. That'll go to ground. That's your negative 15. Stick it on there, right next to the damping MOSFET. Okay. Here, I've taken this from the output of the ADG 333. What I've done, there's a small resistor here. I got rid of it. I put a 470 ohm metal film resistor there. Now, the output of this device actually goes to the far end of that resistor where I'm touching. And this end closest to the device heads up here. There was a diode here, which is a 3 pin diode, just a BAV99, I think it was. I got rid of that, get rid of it, it's not needed. And get rid of the transistor here, which is BC 857 or 859. It's a PNP one anyway. Get rid of that, flick that off, flick off that, and on the output of where that transistor was, on the emitter, this is the output from the totem pole. It goes on this position here. Like I say, I've only tacked this on. It's just experimental. But I'm going to clean it up, and it's going in the newer detectors with these newer devices. You can see them there. You can see I've had a few devices on. There's a lot of resin and stuff sitting around there, and the white paint doesn't help on these either. So that's how that wires in, and it just corresponds exactly the same. Oops, there we go, as per the drawing here. There's nothing really hard. That one there, that's your +5. This is your input off that 470 ohm resistor I put in. But you just copy it, do a freeze frame and do it off the video. Your output here, which is basically the green wire. The green wire, that's it there. $5. And if you want to get really, really clever and smart, you could, on this pin 20 coming in, you could just, if you really wanted to, you could cut the track on pin 20, and this here you could make. You'd probably have to buffer it, so you'd probably need 4 transistors, 2 like this, driving another 2 the same. Get more gain, or if there's some super gain transistors you can get, you can use those as well. You could do a double buffer, but because I've got this already here inside the chip, the main problem is if you start loading this and asking it to do too much. But because on like on the board I put that 470 ohm resistor, it does take a lot of load off this chip, and the output is a lot cleaner, and there's enough gain here for it to drive quite nicely. It drives those MOSFETs beautifully, a lot better than how they're driven directly off this ADG 333. I hope that makes sense. Yeah, and like I say, I've been filling these up with these capacitors as well. That's the smallest capacitor you can get for a fairly high capacitance, and that's the 4700 at 6.3, and I just stack as many as I can within reason, 3 aside. If you're getting 10,000 microfarads of capacitance on the 5 and 15 volt rails in these detectors, you're doing quite all right. So like I say, this has just been purring away. Yeah, during the hours before school kids get home, that won't even have a murmur. There won't even be the slightest of any warble in the audio on this. It is just TVs being on in the house and people using computers and whatever. I mean, I've got the router in the room too, which isn't very conducive to a low noise environment. And I've got this LED light on here. I'll kill it, see if it makes any difference. Probably not. It's probably the switch mode power supply for it, which is actually plugged in and on. So I don't want to lean over the back of the bench and fiddle. But yes, little switch mode plug packs are over there, and they all make noise. I haven't found one that's quiet yet. They all make noise. These detectors will just pick it up. They're so sensitive. Now, what else was I going to do? I was going to do something else too. Now, yeah, there we go. Hear the noise come now? Just now. I think it's because I turned the light on and off, and it's the switch mode's probably trying to get maybe it's a discontinuous mode, switch mode, and it's on a different switching phase or something now. Just because I did that, I used to design this stuff years ago, and I keep away from it nowadays. Switch mode power supplies used to make up high power ones, not little toy ones like that, little 10-watt things. I used to make them up, a couple of kilowatts. Yeah, so this is the latest way of doing this. I've still got other boards and things on the other side. I'll just turn this off. Droning away. You got to be careful, because eventually, if you keep unplugging and plugging and all the rest of it, you know what's going to happen? You're going to destroy these Mylars. They do not like being plugged in and unplugged. These ones have probably been plugged in and plugged out. Actually, it's probably on the second set of them, and many hundreds of times. And on this side of the board, I've got the multi-chip boards in there. There's all the capacitors. I've changed the MOSFETs down there. I don't know if you can see little black things way down the bottom. I've on this one I've changed the output filter. You know, like I say, a lot of things I do to these detectors to start with are all theoretical. Then I have to prove it that it actually works. So that's that one. Um, I've been doing a few of these for people. There's one over there. I don't know where it is. Where is it? There it is. There, that one there, sitting there with a stack of capacitors in it. If you can see it, got some extra boards and capacitors, and there's another experimental. Whoops, where am I? Trouble is this camera. I don't know where I'm pointing half the time, and especially when it's zoomed in like that. Here we go. There's another one there. That's the initial one I did. I was pushing the frequency limit on that whilst using that totem pole driver. And with the new transistors and the driver, I can get a little bit faster clocking speed out of it. And it is extremely sensitive now. These detectors are very, very sensitive, and they'll go very, very deep. When you can get the extra sensitivity, it does translate onto larger, deeper targets, because normally you just wouldn't have that receive sensitivity to get those fringe signals, and now you can. So, you know, as a quick, I should do this. I know I keep saying this. I should do this and I should do that, but I'll put this over here. Okay. Now, what I'll do. Okay. Okay. Here we go. This is. I'll zoom out. Whoops. I'm flicking my test targets on the floor, I think. That's a GPX 5000. This one here is untouched. This one there's a Minelab sticker on it. It's probably got another Minelab sticker on it somewhere, has it? I don't know. Well, they took it off, put Velcro on it anyway. So it's got a Minelab sticker on it. What I'll do, I'm going to fire this stock standard 5000 up. We'll fire it up and we'll see how good it goes. I just want to show you a few things between one of these older detectors that's been modified, as I would call it, improved, and a 5. Okay, and that's it. That's as far out I can zoom. So I'll just put this in the factory default. Okay. Yeah, it's factory reset. Straight away, it's noisy. It's noisy. Okay, let's do an auto tune on it. So we'll let this thing do an auto tune. I'll just move this camera back because I can zoom it if need be. I'm losing my test targets, so I have to bob down. I should check the front switches and see where it's actually in. I'm pretty sure I had it turned on and it was in cancel. So there it goes. God, I thought I'd missed the boat there. Let's turn it around. Okay, leave it on fixed. It's in cancel mode. Listen to it. It's in cancel mode. I'm not joking here. We'll put it in normal. It was in enhanced. It's in deep. I don't know if you can hear it so well, but yeah, well, listen. So that's purring away quite nicely. Now this detector will not even pick up that. I'll wind it up, I'll show you. It won't pick it up. This is a standard out of the factory detector. So I'll have to go wind this thing up. Hang on, we'll get this level. And around I go. Now I've got to undo things here. There we go. I know it's a pain doing all this, but it's one man's show. Yeah, okay. Okay, number one. It knows it's there. Well, it's mixing with the noise a bit, I think. Well, the other one, we're getting it up here somewhere. It's me tapping the coil. We'll try number two. We've got number two here. Now I say this detector, I just did a frequency scan on it. It's getting very noisy. So I can't even get the two up as high as the nuts there, the lug mounts. Okay, let's try it on enhance. Try this. This should be an improvement anyway. Wants to pick it up over here for some reason. Or is that just noise coming through? See, with a noisy detector, you're not going to stop on the target. It's just going to sit there and be noisy. Now, I'll flick it over into fine gold. Special. It should be in, because it's factory default setting, it should be in fine gold. Why is that so damn... I'm trying to work out why this is so damn noisy. It's extremely noisy. Even fine gold, it is struggling like anything to hear. I'll put it back into normal. Yeah. It should be quieter in normal and it's not. I'll crank the threshold up. Oh, wrong way. You can just hear the noise. There's a lot of noise in the base of the signal. You know, that's a 5,000. Just to prove a point, I've got another one here. I'll just oopsie, stick that down. I'll get rid of this one, and another factory one, standard. We'll hook this one up and see if it's any better. Because it might be the 5,000, that other 5,000 may have a problem. But I bet it doesn't. Anyway, let's stick that on. We've got some, I'll even do the coil connectors up. Okay, and I'll put this in factory default. Okay, it's in factory default. Go around here. It's in fixed, cancel. It's in special. I'll put it back into normal. Put it into deep. And I'll let it do a frequency scan, right? I guarantee you it'll be as noisy as the other one. Two, one. I'm missing a test target here somewhere. It's probably. Okay. Now, can you hear that? It's just as noisy. And it's done a frequency scan. Oops. I just belted the microphone, so it's just as noisy as the other one. So people tell me, oh, I've got the detector is 5,000, it's noisy. Yes, they are. So what we'll do, we'll get this one here and we'll go over. We're in normal. We'll give it a test with the number 1, so normal timings. I can get it just by touching the. It's got a sweet spot here. But let's see how high we can get this. In the noise, I'm about halfway up on that white mount there, where the other one we could get it on the 4500 up the top. So it's a bit wishy-washy in the noise, but there's nothing there. So let's try. We'll flick it into special, which will be special fine gold. I would expect an improvement. Around that sweet spot again there. That's just woeful. Okay. I'll just go and put this into enhance. Okay. I hope you can hear that okay. Should be able to pick it up on the microphone. I've got the speaker pointing directly. So there we go again. I'm going to leave it at this height so I don't have to keep winding it up and down. But what I'll do now, get rid of that 5,000. There's another one here somewhere too. I don't really think I'll have to go put all the 5,000s on. But just as a matter of interest, I'm going to get this one here. This is, can I do this? Okay. This has a new transistors in it. It's got a couple of extra capacitors right on the front end part of it. It hasn't got a lot of extra stuff done to it. I can make sure that I don't knock things off. That's for that. Hang on a sec. It's over here. I want to make sure I put the right bits on the right detector. Usually I mark them. Whoops. There goes the test targets. The test targets are going everywhere. Back there, please. Okay. Okay. Let's put this one upside down. You just see a little bit what lives on the back of it. Actually, I'm going to turn it around. This is where you do damage to these detectors. If you just whip them around like what I'm doing, and the mylars bend and carry on, it is quite destructive to these. There goes the multimeter leads. We'll get that in. I'll get this one in. Okay. Oh, I don't even know what settings we're in. Hang on a second. We'll just check this. I've probably knocked something off or done something, have I? Hang on a sec. I just want to check this because it's been flipped over a few times, and like I say, I've just got stuff tacked on there. So that's okay. Yeah, I haven't got this going for a decent resistor at the moment. Okay. Okay, don't know why it wanted to warble for when I first turned it on. Okay, let's have a look at this one. Oh, go back to the coil. I'll just have a look at the quickly. Where are we? Where it fixed? This one's. Oh no, it's in normal. In cancel. Beautiful. Okay. I think no. Oh, hang on a sec. I know what it is. Hang on a sec. I've got it. The board's resting on. It's resting on its cables. Hang on. Hang on a sec. There's a loose wire on it or something. I flipped it over too many times. Let's have a look. Where are you? There. There's something not quite right. Goes in a second. There. I'm going to make sure I got this wired up right. Just check my notepad. Yeah, I've got that 5 sitting there. That makes sense. Yeah, I've just wired this one up in different pin connections. It just sounded a little bit like something was loose. Don't know. Could be, it could be. Make sure everything's plugged in. It's not meant to do that. Oh, hang on a second. I know. I know what's wrong with this one. I'll show you what it is. Hang on a second. I think I was doing frequency experiments with this one, pushing it, how far I could get it, and I might be on the absolute edge. So what I'll do, I'll just factory reset it. Okay. Now, dear me. This is what happens when you do this. No edits. I don't believe in doing edits. If it's going to misbehave, you're going to see it misbehave. But I'm going to work out what it is because that's on, that's on, that's on, that's on, it's on. Make sure all that's there. It's on. I'll tell you another secret. Well, secret. Very good thing to know. When you work on these, oh, I have to, damn it. I'm going to have to drop this down again so you can see. Right, I might point this out because it's quite worthwhile. When you go to work on these, I might have mentioned it before, but I don't know, people might have forgotten. If you can see two capacitor pins, I'll get this out of the way. I'll lift that up. If you see the two capacitor pins, I'll get my piece of wood. I don't want to do this with anything metal. There's from the top side of the board, one there and one there. They've got that surface mount resistor between the pins. But that one there and that one there. This capacitor is 15 volts on it. If you play around with anything here, with that with power still stored in that capacitor, it's going to blow these up, and it's going to blow up if the little drivers there. Oh, yeah, this has the diode left in circuit. I think I might flick that out as well. But anyway, what you do is get a pair of side cutters or something that I've got here, and just short out that capacitor. Crackle, crackle. Okay. Make sure it's dead, because if you don't, and you start, if you solder, you connect a drain to gate or something by mistake with your soldering iron, or touch something to something else, it'll take things out. It'll blow it up. It's quite critical to do. Actually, when I just did that, there was a lot of crackle crackle as it discharged. So why this is screaming, I don't know, but I would say that something's not connected properly. That's not there, 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 there. Let's make sure I got my. I usually very quickly just tack solder some of these things on. Okay. Oh, I know what it is. I know what it is. I know what it is. I took the feedback capacitors out of the circuit. Normally there's, I'll put this down. Normally, you can see those little bits there that are unsoldered. They're the feedback capacitors for both input channels. I've dropped them out. They're usually 68 picofarads. And you can change the value of those depending on how things are set up. And that's why it's unstable. It'll go completely bonkers. What I'll do, oops, that hit the floor, so that's no good. That's why I have lots and lots of capacitors. Okay, what I'll do, and this is going to be in real time, if I can find my tweezers, there's some. These will have to do. Most of my stuff just continually just pours onto the floor like a waterfall, right? It's just the way the bench is set up. So what I'll do, I'll get these are only 10 picofarads. It's probably enough to stop it carrying on like a pork chop. So I'll just tack him on there. These aren't my final values. But if you don't have your feed on your op amp feedback resistors, if they're not bypassed with some feedback capacitors, it's going to scream like a banshee and be unstable, and that is exactly what it did. So now I've got two 10 picofarad capacitors in the feedback loop. That should make it behave. Okay, I'll get that there. Get this here. You really want 4 hands to do this. That's all right. Hang on, we'll get it in. Got to put these connectors in, and I'll flip it over so I don't stress out the mylar. Now, just by adding those two capacitors, this thing will be much more quiet. So, zoom out again. Plug in some power. Okay, and I'll turn it on, and it should work like a charm. Don't make a liar out of me. Hang on a sec. It definitely solid. 10 picofarad is enough of those there. You don't need to put 68s in there. There's reasons to change the capacitor values depending what you do to the circuit. So let's make sure. I'll put a bit of fluxy solder on there, just make sure they're actually stuck. Should be. Okay. On. Battery there, 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 there. That's correct. Correct. Supply there. Okay. It's very strange when the detector you were working on was working perfectly, and then it starts misbehaving. We'll see what goes on. Try again. Now, you can hear it wants to take off. I think what I was doing also was I was actually changing the timing. I had the timing way too high. And what happens if you crank it too far, the receive will start trying to get back into the transmit. But anyway, that's what happens when you're trying to do 100 things at once on a poor detector. So the way it goes, it's working. I don't know. Okay. So we've got the little tiny one. This detector here, with the way I've set it up, it's clocking a lot faster, but I'll just wind this up. I'll get that straight. I'll show you this. This detector is quite amazing. Okay. And around we go. You watch this one. This is really good. Okay. Okay, it's stable. I should have measured the frequency on it where it is, but I know it's clocking quite fast. It's fixed normal mode, and I'll use the tiny little one on it. as you can see, it's leaving the 5000s for dead. I mean, where we had the sweet spot with the 5000 was around here somewhere. This one too, we can get right at the top there near that nut. But the thing is, this detector is so much more better behaved, and it hasn't got any. This has got nothing special done to it in the gain stage or anything, either as the other one. I took the gain board out of the other one I was doing, just to make it a more easy comparison. And what I'll do, I've got the two banger, and we'll try out the two on this and just get an idea. 5000 can never do that. This is working extremely well, and I would say, oh my god, that's bloody amazing. I would put a bet on it that, in my opinion, I'd win the bet by saying that a 6000 wouldn't be able to pick that up. No way. That's really, really getting there. Look at that. I don't know if you can hear it. I'm leaning away from the speaker, but I'll bring it down a bit. But it's picking up about here somewhere. So that's pretty good. When that's in normal mode too, by the way. It's not fine. Well, it hasn't got fine gold on it, but it's nothing special. I'll just flick it into enhance. So this is in enhance now, and I know what it is. I've still got the frequency cranked a little bit too high on it. Enhance uses shorter, sharper timings, and it does tend to go a bit more crazy. But this will be a complete. I've got the thing turned right down now. It's on the verge of being unstable, so I've got to redo the pulse timings on it. It's not right because I haven't got a timing capacitor in there at the moment. I'm just got it padded just to see how fast I could get it. So I'm gonna have to do a bit of work on that. But just to give you an idea too, how far you can push this. This one here is really, really pushing it. I think I've got to put some more capacitance across that the feedback resistors on the op amps, or else it's going to be too unstable. But just give you an idea the direction you can go. It's still, when it's in normal mode, it's so much more quiet than the 5000. And like I say, I've got this thing. I'm pushing. I'm really pushing how fast and basically how much I can get out of it before it all falls over. So we'll push it to its limit, and we'll come back probably maybe 10%. So we won't have any instabilities using it in the goldfield, because that's one thing you don't want. So yeah, we'll give it another kick. Yeah. So I put it back into normal mode. Normal's got greater spacing, so we're not going to get the receiver coming in on the, or the transmit coming in on the receiver. So where that's operating now in normal mode, I will probably more than likely be able to improve on that and get it working, maximum enhance. I was flicking into where am I? Hang on. Oh dear me, that one special. That should be sensitive extra, I think, if I did a reset on it. So at the moment, it's running in sensitive extra. And look at that, sensitive extra up here. It's amazing, isn't it? And you won't get that on the other detectors. But the thing is, see, I'm leaning towards the detector and it starts going noisy. I think it's the wireless microphone. I'll lean towards it again. Yeah, it's the wireless microphone that I got clipped on the shirt, making that noise. So if I get right away from things, I wonder if it. Oh, down you go. Go on, you beast. What happens if I'll get right away from it, as far away as I can. I'll move the camera away too, because the camera's pretty close to the coil and the detector. I don't think it likes it too much, but we'll see how we go. Okay. So, camera is probably, no, 25 inches away from the detector. It's probably within 18 inches of the coil. Sounds quiet. Nothing wrong with that. Give it a. That was a decent target for it, so it's working really well. So the boards, the way I'm driving it, it really does get a lot of the noise out of the detector. All we're going to do now is refine this new upgrade, and it should be very, very good. Anyway, God, that's an hour and 13 minutes. Like I say, I don't edit, and if you don't like bits of it, skip forward. Whatever. Not a popularity contest. And there we go. Someone's trying to ring me now, so I better get off this. Catch us later, and I'll take the phone call.